we can change the base of logarithms. For example, if I have log to base a of x, I can change this to end up with log to base b of x over log to base b of a. So when you change the base of logarithms, what happens is the x goes up and the a goes down. Okay, so the x goes up and the a goes down. It's just as simple as that. And I'll look at some examples to show how this works. Use the change of base formula to evaluate these two three significant figures. So this is what we have. Now I'm going to change this to something that we can plug into the calculator. So when you change the base, think about something that you can plug inside the calculator. So there are two options. I can change this to the base of 10, or I can change this to the base of e, ln. So I'll change it to the base of 10. So I'll have log to base 10 of 9 over log to base 10 of 4. And all I need to do is to plug this in the calculator, and I should be able to get my answer. So if you go on your calculator, just plug in, and I may have to use the fraction button. So log 9 over log 4, and my answer is 1.58. So I'll have 1.58 as my answer. Here is another question involving change of base. Log to base x of 3 is equals to a, right? So you are given that condition and that condition. Find log to base 3 of 6 in terms of a and b. So log to base 3 of 6 in terms of a and b. So I'm going to change it because I'm given a and b in terms of log x. I'll try to change this to the base of x. So this will be log to base x of 6 over log to base x of 3. Remember, 6 is going up, 3 is going down. So what I'll end up with here is, from the conditions that I'm given, log to base x of 6 is b, so that will be b over a. And that's the answer. That's it. So we're going to look at a couple of examples, more practice on how to change bases. Now here we are given two conditions. Log to base a of 2 is x. Log to base a of 6 is y. We need to write each of these guys in terms of x and y. I'll start with a. So I'll change the base log base 2 of 6 so that I end up with base a. So log to base 2 of 6 will be log to base x of 6 over log to base x of 2, which will be equal to y over x. And that's it. B, log to base 6 of 2 will be equal to log to base x of 2 over log to base x of 6, which will be equal to x over y. C, we have log to base 2 of 36. So this will be equal to log to base x of 36 over log to base x of 2. Now 36 is 6 squared, so log to base x of 6 squared over log to base x of 2, which will be 2 log to base x of 6 over log to base x of 2, which will be equal to, now we know that this here is y, so my answer will be 2y over x, because log to base x of 2 is x. D, log to base a of 24. Now we know that 24 is 6 times 4, so this will be log to base a of 6 multiplied by 4, and I can expand that using lots of logarithms to log to base a of 6 plus log to base a of 4. This will be equal to log to base a of 6 plus log to base a of 2 squared, because 4 is 2 squared, which will be log to base a of 6 plus 2 log to base a of 2, and that will be y plus 2x. E, we have log to base 6 of 12. So this is same as log to base a of 12 over log to base a of 6, which will be log to base a. Now 12 is 2 times 6, and we can expand that using laws of logarithms to say this will be log to base a of 2 plus log to base a of 6 over log to base a of 6, and that will be equal to x plus y over y. F, we have log to base 2 of 3. Let's change the base. So that will be equal to log to base a of 3 over log to base a of 2. Since in our conditions we don't have 3, we can rewrite this as log to base a of 6 divided by 2, because 3 is 6 divided by 2, over log to base a of 2. And using laws of logarithms, this is same as log to base a of 6 minus log to base a of 2 over log to base a of 2. And this is same as y over x divided by x. Here is another question. Given that log to base 4 of a is b, express y in terms of b. So in part A, I'll try and rewrite this so that I have something similar to what I'm given in that condition. So the first step is I can bring this to the left using the laws of logarithms. So this will be 2 log to base 4 of a. Fortunately, log to base 4 of a is b, so my the right hand side will simplify to 2b, and therefore that means that y will be equal to 2b. That's it. For part B of this question, I have y is equals to log to base 16 of a. So my first step will be to try and change the base to base 4 because that's what I'm given in the condition here. So log to base 4 of a over log to base 4 of 16. Need to simplify this. So the numerator remains as it is. The denominator will be log to base 4, but 16 is 4 squared. And the main reason why I'm changing it to 4 squared, I want to find out of simplifying that denominator. So this will be log to base 4 of a over, now I can bring this to the left. So I'll end up with 2 log to base 4 of 4. Fortunately, log to base 4 of 4 is 1. So that's gone. What I will end up with is log to base 4 of a over 2, which is m as b over 2. So my equation will be y is equals to b over 2. Part C of this question, you have log to base a quarter of a squared. So the first step that I'll do is to change the base. So I'll end up with log to base 4 of a squared over log to base 4 of a quarter, which will be, and from the numerator I can bring the 2 to the left, so I'll remain with 2 log to base 4 of a over log to base 4. A quarter is same as 4 to the power negative 1 if you remember negative indices, and which means I can bring the negative to the left. So I'll end up with 2 log to base 4 of a over negative 1 log to base 4 of 4. Log to base 4 of 4 is 1. So the right hand side will simplify to 2 log to base 4 of a over negative 1. From the condition that you're given in the question, log to base 4 of a is b, which means this will be equal to 2b over negative 1, which is negative 2b. So the equation will be y is equal to negative 2b. For D, we have y is equals to log base 1 over 16 root a. This can be changed to base of 4. So log to base 4 of square root of a is same as a to the power a half, and log to base 4 of 1 over 16. So what we'll end up with here is log to base 4 of a to the power a half over log to base 4 of 4 to the power negative 2. 16 is same as 4 to the power negative 2. So 1 over 16 is same as 1 over 4 squared, which is 4 to the power negative 2. Okay, if you remember negative indices. So back to our question. We can bring these powers to the left. So what we'll end up with here is a half log to base 4 of a over negative 2 log to base 4 of 4, which will be equal to a half b. Remember, log to base 4 of a is b, over negative 2, because log to base 4 of 4 is 1. Now, here a half of 2 is a quarter, so that will be negative a quarter b. So our final relationship between y and b is y is equal to negative a quarter b.